Welcome to part 3 of the final exam review packet. Number 18, evaluate tangent of the arc sine of 1/3. So we have some sort of theta here, and we're trying to find the tangent of it. So for this problem, it's going to be helpful to draw a triangle, like we've done many times before. I just pick one of the acute angles to name as theta, and I see the arc sine of 1/3. Well, sine is opposite over hypotenuse. So I'm going to go ahead and label the sides like that. And then for tangent of theta, it's opposite over adjacent. So I need to find the adjacent side. I'm going to call that x. So x squared plus 1 squared equals 3 squared. I'll subtract 1 from both sides. X squared equals 8. So x is radical 8, which can be simplified. So 8 is 2 times 2 times 2. We have one pair of 2's, so we get 2 radical 2. So tangent theta is going to be 1 over 2 radical 2. So to rationalize the denominator, we'll just multiply by 1 in the form of radical 2 over 2. I'm sorry, radical 2 over radical 2. And we get radical 2 over 4. Okay, number 19, use an inverse trig function to write theta as a function of x. So looking at my triangle, I know the hypotenuse is 4, and the side length that's marked x is the adjacent side. So I know that cosine is is adjacent over hypotenuse. So cosine theta equals x over 4. So to quote-unquote undo the cosine, I take the arc cosine. So theta is the arc cosine of x over 4. Okay, number 20. Probably the most challenging problem on the review packet for most. It does tell us to factor and simplify. So here I'm going to factor by grouping. I look at these and I say, oh, they both have a secant squared in them. So I can factor out secant squared x. Then for the leftover factors, I simply divide these terms by secant squared. So secant squared cosecant squared divided by secant squared is just cosecant squared. And then secant squared divided by secant squared is 1. So inside the parentheses, I have a cosecant squared minus 1. Up here, I have a negative cosecant squared plus 1. So if I factor out negative 1, I'll also get a cosecant squared minus 1. So since these are the same, I can rewrite this as secant squared minus 1 times cosecant squared minus 1. So looking at your Pythagorean identities, secant squared minus 1 is tangent squared, and cosecant squared minus 1 is cotangent squared. And since these are reciprocals of each other, we get 1. Okay, 21. Verify the identity cosecant over sine minus cotangent over tangent equals 1. Okay, so we're going to try to make the left side equal the right side, which in this problem is 1. So you look, and you could try to find a common denominator. If you did, it'd be sine tangent. Don't know if that's going to help too much. So what I'm going to do is I'm just going to change everything into sine and cosine, which is one of the strategies that our book taught us. So I know cosecant is 1 over sine. I know cotangent, well, now we'll go ahead and do it. So cosine over sine, and that's sine over cosine. So when I simplify these, this is 1 over sine squared. Now, if you're having problems figuring out how I got that, take a look over here. This is equal to 1 over sine x divided by sine x, which is the same thing as 1 over sine x times the reciprocal of sine x, which is 1 over sine x. So you see 1 over sine x times 1 over sine x would be 1 over sine squared x. Then over here, I get cosine squared over sine squared. Do the same thing over here like I did over here with these fractions if you're having problems figuring out how I got this. So since I have a common denominator here, which I didn't realize I was going to have that at first, I can go ahead and rewrite this as 1 fraction. Oh, well, look at there. I know that 1 minus cosine squared is sine squared. So sine squared divided by sine squared is equal to 1. Okay, number 22. Find all solutions in intervals 0 to 2 pi. Okay, so we've got a secant squared and a secant. Now, if we just had a secant, or secant terms, or just had secant squared terms, we try to get that by itself. But since we have a squared and a non-squared term, we're going to go ahead and see if we can factor. In order for factoring to be useful, we need to get 0 on one side. So I'm going to subtract secant and 2 from both sides. So I get secant squared x minus secant x minus 2 equals 0. So now this is very similar to factoring this equation. Instead of x and x squared, I've got secant and secant squared. So we look, what two numbers multiply to negative 2 and add up to negative 1? Well, negative 2 and positive 1. So I can rewrite this as secant x minus 2 times secant x plus 1 equals 0. So now I solve for secant. I get secant x equals 2 and secant x equals negative 1. So I know secant is the reciprocal of cosine. So this is saying that cosine of x is the reciprocal of 2, or 1/2. And over here, the reciprocal of negative 1 is, well, negative 1. So now I'm going to look on the unit circle, and I'm looking for x values that are either 1/2 or negative 1. So for 1/2, I see pi over 3 and 5 pi over 3. And then for negative 1, I see that it's at pi. So those are the three solutions in the interval from 0 to 2 pi. If I ask for the general solution, then you just add plus 2 pi n to each of those three solutions. Okay, 23. We're trying to simplify this expression. So we're going to need to use the sum and difference formulas for tangent, which are located on the formula sheet that I'm going to give you. It's down here. So I'm going to be using this formula to rewrite both of those expressions. So for tangent of theta plus pi over 3, we get tangent of theta plus tangent of pi over 3 over 1 minus. Now take a look at the answer or the formula sheet. If I use the plus here, that's the top symbol. I use the plus on the top because that's the top symbol. But on the bottom part of the fraction, I'm going to use the minus because it's on top, just to make sure you understand what that does. So I get 1 minus tangent theta tangent of pi over 3. Now, that's just this part here. Now, I need to use the difference formula. So I get tangent of theta minus tangent of pi over 3 over 1 plus tangent theta tangent of pi over 3. Well, I don't know what tangent of theta is, so that's just going to stay tangent theta. But I do know the tangent of pi over 3. Tangent is y over x. So in this case, I get y, which is radical 3 over 2, divided by 1/2, which is just radical 3. So wherever I see tangent of pi over 3, I'm going to substitute radical 3. Okay, so I'm trying to simplify this, but I can't simplify these as, or combine these as is, because I don't have a common denominator. So for the common denominator, it's just going to be the product of these two. So for the left fraction, I'm going to multiply by 1 plus radical 3 tangent theta over 1 plus radical 3 tangent theta. And for the left fraction, or the right fraction, I'm going to multiply both the top and bottom by 1 minus radical 3 tangent theta. Oh my goodness, how ugly. Well, it's actually going to simplify very nicely. So if you take a look at the bottoms, you can go ahead and FOIL that out. But since it's in the form a plus b and a minus b, I know my denominator is going to be 1 minus 3 tangent squared theta. Okay, now for the top, I'm going to FOIL. So 1 times tangent theta is tangent theta. 1 times radical 3 is radical 3. Radical 3 tangent theta times tangent theta is radical 3 tangent squared theta. And then radical 3 tangent theta times radical 3 is 3 tangent theta. Now the right side, 1 times tangent theta is tangent theta. 1 times negative radical 3 is negative radical 3. Negative radical 3 tangent theta times tangent theta is negative radical 3 tangent squared theta. And then negative radical 3 tangent theta times negative radical 3 is 3 tangent theta. So if you look at the top part of the fraction, we notice that some terms cancel out. The radical 3 and the negative radical 3. The radical 3 tangent squared theta and the negative radical 3 tangent squared theta. So we're left with tangent theta plus 3 tangent theta plus tangent theta plus 3 tangent theta. That gives us a total of 8 tangent theta over the denominator of 1 minus 3 tangent squared theta. Okay, 24. We're trying to simplify this expression. You may be thinking, wow, how does all this equal cosine x? Well, we'll just use the sum of difference formulas, which are located on your formula sheet. There's, at the bottom, we see sine and cosine. So for cosine of x plus y, I get cosine x, cosine y, minus sine x, sine y. And that whole thing's multiplied to cosine y. So this I just used the formula. Notice for cosine, if I use cosine plus, or u plus v, over here the top symbol is minus. So I need to use cosine u cosine v minus sine u sine v. And for sine, we get sine x cosine y plus cosine x sine y, all times sine y. So we'll go ahead and use the distributive property. So I get cosine x cosine squared y, because I have a cosine y, times a cosine y, minus sine x sine y cosine y. Then for the right side, I get sine x cosine y sine y plus cosine x sine squared y. Notice that these two terms are opposite of each other. So I can rewrite this as cosine x cosine squared y plus cosine x sine squared y. So both these terms have a cosine x. That means I can factor out cosine x. And what I have left is cosine squared y plus sine squared y. Now, sine squared plus cosine squared is 1. So cosine x times 1 is simply cosine x. Okay, 25. Find all solutions in the interval 0 to 2 pi of cosine squared x minus cosine 2x. So with a problem like this, we can't factor, because this is a cosine x and this is a cosine of 2x. So what we're going to do is we're going to use our double angle formulas to see if we can rewrite the cosine of 2x in a way that might make it easier to factor. So I look at my double angle formulas for cosine, and I see I've got 3 choices. Cosine squared minus sine squared, 2 cosine squared minus 1, and 1 minus 2 sine squared. Well, when we factor, it's not really feasible to have both sine and cosine. We usually just want one of the functions. So I'm going to use the middle one, 2 cosine squared minus 1. So I'm going to go ahead and distribute the negative. Now I can combine like terms. We'll go ahead and subtract 1 from both sides. Divide by negative 1. And then take the square root. So the absolute value of cosine x equals 1. So that means cosine x equals plus or minus 1. So where on the unit circle is cosine either equal to 1 or negative 1? I see it's 1 at 0. And I see it's negative 1 at pi. So those are my solutions, 0 and pi.